Hey everybody, and welcome to the mini lesson on 4.4 climate change. Let's get started. So the first thing you need to know are greenhouse gases. What are they and what are examples of them? As you can see here, some common formulas I'm sure we all know: carbon dioxide, water, and methane. These are all great examples of greenhouse gases. Obviously, water is water vapor. A greenhouse gas is one in the atmosphere that retains heat. And as I said, these are the three most common, and then there's also nitrogen oxides, which are less common. Greenhouse gases basically exist in these different forms, and they have different effects on the atmosphere, which we're going to go into right now. So the impact of greenhouse gases, there are two things that you need to consider. One is the ability to absorb long-wave radiation, and then the abundance in the atmosphere. And the abundance can be evaluated by either the rate of release or persistence in the atmosphere. So if we look at CO2, it's extremely abundant and extremely persistent, but not necessarily as strong, or doesn't necessarily have the best ability to absorb long-wave radiation. Now, water vapor has a very fast rate of release, but does not persist in the atmosphere nearly as long as CO2, which can remain for many years. And finally, methane has a very strong ability to absorb long-wave radiation, but it's not found as much in the atmosphere. Now, the greenhouse effect is basically 5 simple effects that can explain why global warming happens and how it is responsible for it. So as you can see on this next slide, I will go through and explain the 5 steps. So step 1 starts over here, and this is solar radiation from the sun enters Earth at 100% and passes through the atmosphere. Once it does so, the atmosphere retains or absorbs about 25% of the radiation, so 75% actually reaches the Earth's surface. The Earth then absorbs a decent amount of this radiation, and almost all of the shortwave radiation it absorbs, and then it re-emits longer wavelengths of radiation in the form of heat and heat energy. As this heat rises back up, it hits the atmosphere once again. The atmosphere is going to absorb about 85% of this heat, but the last 15% is going to be repelled back towards the Earth's surface, which then raises the temperature of the Earth. So that's what you can see here, this heating, and that is basically the process of global warming. Now, if this process did not happen, if there was no such thing as the greenhouse effect, the temperature of the Earth would be basically unlivable for humans. I think it would be negative 18 degrees Celsius, which is extremely, extremely cold. So the greenhouse effect is not necessarily a bad thing, but because humans have increased the concentration of CO2 in the air and therefore increased the amount of heat pushed back towards the Earth, then this is why global warming has become harmful. Now, when I say carbon dioxide, it's because the atmosphere is made up of carbon dioxide and other things. So when the concentration of carbon dioxide increases, the amount of heat repelled back also increases. But this is something we're going to get into later in the lesson. So, concentration of greenhouse gases. How does the concentration of greenhouse gases affect life on Earth? Well, it's going to obviously cause higher global temperatures, more frequent and intense heat waves. Certain areas maybe become more prone to droughts or floods, increasing the severity and occurrence of tropical storms, especially, in the Caribbean and near the equator, where those tropical storms are already very common. And finally, changes to ocean currents. So obviously, these are all pretty important changes that we need to consider when evaluating the effect of global warming. Now, like I said, there is a direct correlation between the concentration of CO2 within the atmosphere and global temperatures. As you can see by this graph, where red line is represented by temperature and the blue line represents the CO2 concentration, the two are almost directly related to each other. As one decreases, the other may decrease, and as one increases, the other may increase. So when in 300,000 years ago, when concentration of CO2 was decreasing, so was the global temperature. But then about 50, maybe 100 years ago, there's been sharp inclines in the CO2 concentration, also causing sharp inclines in temperature. So studies have thus shown that increase in CO2 concentration in the atmosphere have led to increased global temperatures on average. They've also proven this by collecting ice cores from either the north or the south. They drill into ice and then remove the ice from the area so that they can evaluate how much CO2 is actually in the ice. By doing so, they're able to further deduce the correlation between CO2 and global temperatures. Moreover, as humans have performed combustion more in recent years on fossil fuels, and of course, like we learned in the last unit, combustion causes a great release of CO2 into the atmosphere. This is how global warming has increased exponentially within just the last 100 years, because humans have advanced during the Industrial Revolution, and then these advancements have led to more utilization of fossil fuels and combustion, and therefore more CO2 within the atmosphere. Now, one drawback of CO2 in the atmosphere is ocean acidification. So when CO2 dissolves within the ocean, it forms other molecules such as bicarbonate, carbonate, or carbonic acid. These lower the pH of the water because they release hydrogen ions into the seawater. Now, studies have shown that pH has been lowering within seawater consistently over the past 300, 400 years. So as CO2 levels have risen, the pH of sea has fallen because more CO2 is entering the ocean and more is dissolving, and that is how the pH has decreased. This effect is actually so dramatic that scientists believe that by the turn of the next century, the ocean could be 150% more acidic. As you can imagine, this would have an extreme effect on ocean and marine wildlife. Animals like oysters, clams, and sea urchins, which need... Oh, sorry, there's a typo. That should just be C. Although they may need carbon to form like their bicarbonate shells or things of that matter, it'll be too much for them to survive in these climates. The high acidity will also erode coral reefs to the point of extinction. Finally, global warming and climate change truths. There's obviously a lot of bias and debate over whether global warming is actually backed up by scientific evidence and should be a concern within our generation. And the simple answer is yes, it is. It is real, and it is something that humans need to be concerned with, especially our generation, because it will help to sustain life on Earth, and not just humans, but other animals will also be affected by our actions. I think about 97% of scientists today believe that global warming is a result of human activity. Like I said, the combustion of fossil fuels has led to increases of CO2 in the atmosphere. The effects of climate change are apparent. It will harm agriculture, health, the environment. Species will go extinct. The Antarctica is already rapidly losing ice. And even though people may say that, no, it's not true, temperatures have not been rising, scientific evidence shows that in recent decades, temperatures have been the highest they have ever been. So global warming is real, climate change is real, and it is a major concern. Now, just to recap this unit, let's go through very quickly. Greenhouse gases, the main ones are water vapor, CO2, and methane. Methane is very strong. It has the ability to absorb long-wave radiation, about 33 times as strong as CO2, but it is not nearly as abundant as CO2 is in the atmosphere. Therefore, CO2 is the most prominent of the greenhouse gases and plays the largest role within global warming due to its high abundance and also its ability to persist within the atmosphere for many years. We learned about carbon cycling, how it goes through different carbon sinks and carbon fluxes. And it takes a long time for CO2 to officially leave the environment. So this is how it's very persistent. And then also water vapor, which enters, has a high rate of release, but it's not nearly as persistent as CO2 within the atmosphere. There are 5 main steps to global warming. First, radiation enters from the sun, passes through the atmosphere, of which 25% of it is absorbed. The other 75% goes towards the Earth, which absorbs short wavelengths and repels longer ones. These longer wavelengths are re-emitted into the atmosphere as heat energy, and when those pass through the atmosphere, they are then reversed, and about 15% is sent back down towards the Earth. This 15% is what causes global warming. It causes the average temperature of the Earth's surface to increase. And so as this process is amplified by CO2 concentrations, the global warming is also amplified. So CO2 and global temperatures. How are CO2 and temperatures related? Well, just look at this graph. As you can see, they're basically completely congruent with each other, and CO2 within the atmosphere increases temperatures. In addition, more CO2 leads to ocean acidification, like we talked about, and global warming is real. So thank you for paying attention to this lesson, and I hope you learned something.